Hi everyone, and welcome to our video on using an addition or subtraction formula with cosine. Alright, so with cosine, let me scroll again. We broke it down into words. Cosine, addition or subtraction. I know it's always cosine, cosine, and then sine, sine after. The sign right here where I'm swirling the plus changes to minus. Okay, so the sign becomes the opposite. But then that's it. Okay, so notice the difference between sine and cosine's addition or subtraction. All right, so let's break this one down. So this one's in radians. I mean, we could change it to degrees if we want. Notice again, this angle is not on the quoted unit circle. So we know when it has like a denominator of 2, 3, 4, 6, those ones are on the quoted unit circle that we've been using for most of the class. All right, but we know there's a ways to rewrite this now that we have an addition formula. So what I'm going to do is I'm going to say, well, let's set it up. Cosine of, because this is negative, I'm going to do something minus here. And then what I like to do, so I think radians are nice because I just set up the fractions right away with a blank. And I know that these two numerators need to subtract and give us -5 eventually. But they also need to be able to reduce with the 12 down below. So for instance, like if I did, so I'm going to erase this one. If I did 1 and 6, that does equal -5 pi 12ths, but this first fraction doesn't reduce. Okay, so I need it to reduce so that I can use the unit circle. So let's try again. Okay, so I'm also going to erase this one. So say I did 2 and 7. Yes, again, that does add up to -5 pi over 12, but the 7 over 12 doesn't reduce. Okay, so that's no good either. So let's try one more time, or however many times we need to. But I think we can do it right here as 3 and 8. And then we can see, oh yeah, 3 reduces with 12, 8 reduces with 12. So, and 3 minus 8 is -5, and then the pi still attached, so this is good. Okay, and then now in words, I'm going to rewrite it. So I know it's cosine. Well, this 3 pi over 12, let's reduce it. That does become pi fourths. And then the next one becomes 2 pi thirds. So notice now these are both on the quoted unit circle, and we can evaluate them without a calculator. All right, so now let's rewrite them using the formula. Okay, so the formula tells us if I have cosine of something minus something, I should do cosine of the first angle and cosine of the second angle, and then change the sign. Let's do plus sine of the first angle, sine of the second angle. Just like that. So that's the whole setup. And then now we can use our unit circle. So I know pi quarters puts us there and 2 pi thirds is there. And so we can use that information and start to plug in our cosine values and sine values. So we would get square root of 2 over 2. Cosine of 2 pi thirds is -1/2. And then we have plus. Sine of pi quarters is square root of 2 over 2. Sine of 2 pi thirds is positive square root of 3 over 2. And then now we'll multiply through the numerator here. We've got negative square root of 2 over 4. So next one is plus. 2 and 3 multiply to give us 6. It stays under a square root. 2 times 2 is 4. Just like the answer on the left, you can usually stop there. We could rewrite it in different ways. For instance, like square root of 6 over 4 minus square root of 2 over 4. Again, if you switch the order, as long as the signs stay consistent, you're good. And that bottom one is where I'd say, well, if they want a common denominator, it'd probably look like that as the best choice. Okay, so all of those are equivalent. Okay, so lots of ways to get that answer as well. So one more time, so I wrote those up there to get the answer. Well, again, you could have set it up such in a way like 4 pi 12ths minus, let's see, what is it, 9 pi 12ths? That would also work. Okay, so there's different ways we can break it down. That would give us one of those 3 answers as well. Okay, so that's how we can deal with our cosine addition or subtraction formula. All right, so let's take a pause and we'll look at the next topic in the next video. Thank you for watching, and I'll see you next time.